Hey everyone, welcome to another BTM screencast. Today we're going to be going over Chapter 11, Cable Installation. Some of the objectives are to be able to select an appropriate cable type for a residential application, list several NEC requirements for the installation of common cable types used in residential wiring, demonstrate an understanding of the proper techniques for preparing, starting, and supporting a cable run in a residential wiring application. We'll also look to demonstrate an understanding of the proper installation techniques for securing the cable to an electrical box and preparing the cable for termination in the box. We'll also demonstrate an understanding of the common installation techniques for installing cable in existing walls and ceilings. So when you select the appropriate type of cable, it depends on the cable type allowed by the authority having jurisdiction in your area, or the AHJ, the specific wiring application. Many residential building plans will state the required cable type either on the electrical plan or in the electrical specifications. Some of the requirements for cable installation of type NM, also known as Romex. Article 334 covers the installation of requirements for non-metallic sheath cable, or Romex. Section 334.10.1 states that type NM cable is allowed to be used in 1 and 2 family homes, including their attached or detached garages and storage buildings. Requirements for type NM continued. Section 334.15 states that when type NM cable is run exposed and not concealed in the wall or ceiling, the cable must be installed as follows. The cable must closely follow the surface of the building finish or be secured to running boards. Cable must be protected from physical damage where necessary by rigid metal conduit, also known as RMC, intermediate metal conduit, or electrical metallic tubing, EMT, Schedule 80 PVC conduit, type RTRC, marked with the suffix XW, guard strips, or other approved means. Section 334.15 continued. Where the cable is run across the bottom of joists in unfinished basements, it is permissible to secure cables not smaller than 2 6 American wire gauge conductors or 3 8 American wide gauge conductors directly to the bottom edge of the joists. Smaller cables must be run either through bored holes in joists or on running boards. Here's a graphical depiction of the requirements for cable installation if you're running Romex. So here we can see that this is the running board across some of the joists. Up here we have the cable stapled to the joists. Here they are, they're running parallel. And here we have them running through the joists with bored holes. Just keep in mind that cables smaller than 2 6 AWG or 3 8 AWG conductors must be run through the bored holes or be run on the surface of a running board. Keep in mind, the 6 AWG is larger than 8 AWG, and usually we are running 12 or 14. Section 334.15 continued. Type NM cable installed on the masonry wall is permitted to be installed in a listed conduit or tubing. And some of you may have seen this in your basement, the way that it's coming down. We also have examples of this in the lab. Another acceptable method is to attach a running board to a masonry wall, then secure the type NM cable to the running board. Here we have coming down, letting you know this is 20 amps. Running board, and then of course staples. Section 334.17 covers running type NM cable through or parallel to framing members. Some of this we went over already. So the important numbers are the edge is 1.25 inches. If you have that, then you need a metal plate at least 1/16 of an inch thick, used to protect it from nails or screws. If the cable is placed in notched wood studs, joists, rafters, or other wood members, a steel plate must be used, and again, 1/16 of an inch. So in this instance, let's say we have a stud notched out, we would need the metal protector plate going over the face right here. If run along a framing member where the cable is closer than 1.25 inches to the edge, metal protector plates at least 1/16 of an inch must be used to protect the cable. Installing type NM cable in accessible attics is covered in section 334.23. If Romex is run across the top floor of joists or within 7 feet of an attic floor or floor joists, the cable must be protected by guard strips at least as high as the cable. Where the attic space is not acceptable by permanent stairs or ladders, protection is only required within 6 feet of the nearest edge of the scuttle or attic entrance. Section 334.24 states that bends in non-metallic sheath cable must be made so that the cable will not be damaged. When a type NM cable is brought through a hole in a building framing member, the cable must be formed in the jug handle to ensure that the cable is not bent too sharply. And here we have an example of the Romex coming through. Let's say that this is a stud. It's bored through. There's a jug handle right here. Have to make sure that there's a 2.5 inch radius, because this is a 1/2 inch, and as we'll see later on, we need 5 times a 1/2 inch, which gives you a 2.5 inch radius. And at the end, we have a staple. Section 334.30 addresses securing and supporting type NM cable. Non-metallic sheath cable must be secured by staples, cable ties, straps, hangers, or similar fittings, designed and installed so as not to damage the cable at intervals not exceeding 4.5 feet, and no more than 12 inches of every cabinet, box, or fitting. They're to be secured no more than 8 inches from a single gang non-metallic box. And here's a diagram that you can look over. Again, you have to make sure that that is 5 times the thickness of the cable. Installation requirements continued. Section 334.30 also says that flat cables like 14.2, 12.2, or 10.2 Romex must not be stapled on edge, which means you cannot run them together and staple them. Section 334.30a states type NM cables that run horizontally through framing members spaced less than 4.5 feet apart and passing through board or punch holes in framing members without additional securing are considered supported by the framing members. So they're saying that because if these are less than 4.5 feet, which they usually are, they're usually 16 inches on center, this cable will be supported here, and will be supported here. And of course, here we have the jug handle coming up, and that radius has to be 2.5 inches. Section 334.30b allows type NM cables to not be supported under certain conditions. When fished between access points or concealed in finished buildings and supporting is impracticable, as with remodel electrical work in some of the older houses, then there's not more than 4.5 feet from the last point of support for connections with an accessible ceiling to a luminaire or light fixture. It's called a fixture whip. Section 334.80 covers the ampacity of type NM cable. Even though the cable's insulation is rated at 90 degrees Celsius or 190 degrees Fahrenheit, the allowable ampacity of the cable is taken from the 60 degree centigrade column. in Table 310.15b16. If you're using an underground feeder cable type UF, Article 340 allows type UF cable to be used in residential wiring for direct burial applications or for installation in the same wiring situations where you'd use non-metallic sheath cable. When installing type UF cable as non-metallic sheath cable, follow the installation requirements of Article 334. Section 340.24 states that bends in type UF cable must be made so that the cable is not damaged. The radius of the curve of the inner edge of any bend must not be less than 5 times the diameter of the cable. Again, so this is 5 times. Jug handles are needed like those used with type NM, so again, that will be 5 times the diameter. Requirements for cable installation, type AC. Section 320.15 requires exposed runs of type AC cable, also referred to as BX cable, to closely follow the surface of the building finish or be secured to running boards. Exposed runs are permitted on the underside of joists, like in a basement where they are supported at each joist and located so as not to be subject to physical damage. And here we have an example of it being run across joists. Section 320.17 allows type AC cable to be run through or along framing members in a house and must be protected in accordance with Section 300.4. Same requirements as for Romex. If run through a hole that has an edge closer to 1.25 inches to the edge of the framing member, use a metal plate at least 1/16 of an inch to protect that spot from nails or screws that could penetrate the cable sheathing. So again, 1.25 inches from the face and 1/16 of an inch metal plate. Section 320.17. If placed in a notch in wood studs, joist rafters, or other wood members, use a steel plate at least 1/16 of an inch thick to protect the cable. If run along a framing member where the cable is closer than 1.25 inches to the edge, use metal protection plate at least 1/16 of an inch thick. A listed and marked steel plate can be less than 1/16 of an inch thick if it still provides equal or greater protection. So again, with these numbers, 1.25 inches, 1/16 of an inch for a plate. Type AC cable is installed in accessible attics. Section 320.23 requires it to be installed exactly the same way as non-metallic sheath cable. Section 320.24 states that, as with type NM cable, bends in type AC cable must be made so that the cable will not be damaged. The radius of the curve of the inner edge of any bend must not be less than 5 times the diameter of the type AC cable, and jug handles are needed. So again, this is 5 times for each bend and 5 times for the jug handle. As with type NM cable, secure type AC cable with staples, cable ties, straps, hangers, or similar fittings designed and installed so not as to damage the cable at intervals not exceeding 4.5 feet and no more than 12 inches from every outlet box, junction box, cabinet, or fitting according to Section 320.30. Section 320.30c addresses type AC being run horizontally through holes and notches in framing members. In other than vertical runs, so up and down, cables installed in accordance with Section 300.4 are to be considered supported and secured under the following conditions. Support intervals do not exceed 4.5 feet. Armored cable is securely fastened in place by an approved means, no more than 12 inches from each box, cabinet, conduit body, or other armored cable termination. According to Section 320.30d, type AC cable is permitted to be unsupported under the following conditions. Where cable is fished between access points, where concealed in finished buildings or structures and supporting is impractical, such as remodel work in existing houses, which we've covered in the previous slide. Where cable is not more than 2 feet in length at terminals, where flexibility is necessary, like a connection to an electric motor. Where cable is not more than 6 feet from the last point of support for connections with an accessible ceiling to a luminaire, again, commonly called a fixture whip. Requirements for cable installation for type AC. Section 320.40 states that at all points where the armor Type AC cable terminates, a fitting must be provided to protect wires from abrasion unless the design of the outlet or box or fittings provides equivalent protection. The required insulating fitting is many times by electricians in the field called a redhead or a red devil, and that is this piece here. Like all of your conductors are, and then this sits right there. Section 320.80 covers the ampacity type of Type AC cable. It states that Type AC cable installed in thermal insulation must have conductors rated at 90 degrees Celsius or 190 degrees Fahrenheit. Again, this sounds very similar to what the Romex is. However, the ampacity of the cable must be no greater than the amount listed in the 60 degrees Celsius or 140 degrees Fahrenheit column of table 310.15b16. Again, this sounds very familiar. It's the same requirements for Romex. For Type A MC cable, just as with Type NM and Type AC cable, Section 330.17 requires that metal-clad cable be protected in accordance with Section 300.4 where installed through or parallel to framing members. Similar to Romex and Type AC cable, Section 330.23 requires the installation of Type MC cable in accessible attics or roof spaces to comply with Section 320.23. Section 330.24b states that the radius of the curve of the inner edge of any bend must not be less than 7 times the external diameter of the metallic sheath for the style of Type MC used in residential wiring. So as a quick review, for Romex you need it 5 times, and for AC you need it 5 times. For MC it needs to be 7 times. Section 330.30 states that Type MC cable must be supported and secured at intervals not exceeding 6 feet. Again, this is different than Romex and the AC, which were at 4.5 feet. Section 330.30c covers horizontal installation through framing members and allows Type MC cables installed in accordance with Section 300.4 to be considered supported and secured where the framing members are no more than 6 feet apart. Cable ties or other securing methods are not required as the cable passes through these members. Section 330.30b requires Type MC cable containing 4 or fewer 10 AWG or smaller conductors to be secured no more than 12 inches from each box, cabinet, or fitting. Section 330.30d allows Type MC cable to be installed unsupported under the following conditions: where fished between access points or concealed in finished buildings or structures and supporting is impractical. Again, this is the same for AC and Romex. We're not more than 6 feet from the last point of support for the connections within an accessible ceiling to a luminaire. Interlock Type MC cable can be supported up to 3 feet away from equipment where flexibility is necessary. According to Section 330.80, the ampacity Type MC cable is determined according to the table 310.15b16. The final ampacity of the cable must not exceed the maximum ampacity based on the temperature ratings of terminations and equipment. The conductor insulation for Type MC cable must be of a type listed in table 310.104a. It is usually THHN or THWN insulation. Requirements for cable installation for Type SEU and SER. Service entrance cable installation, when used as a service entrance wiring method, is covered in Chapter 8. There are certain situations in residential wiring when service entrance cable is used as a branch circuit wiring method for individual appliances, such as electric furnaces, electric ranges, electric clothes dryers, and as the wiring method for a feeder going to a sub-panel. Section 338.10b allows the use of service entrance cable as a branch circuit or feeder conductors. Branch circuits using service entrance cables as a wiring method are permitted only if all circuit conductors within the cable are fully insulated with an insulation recognized by the NEC. Section 338.10b4 says that in addition to the provisions of Article 338, Type SE cable used for interior wiring must comply with the installation requirements of Article 334 for non-metallic sheath cable. This means that when Type SE for a branch circuit or feeder runs inside a dwelling unit, install the Type SEU or Type SER service entrance cable the same way as for non-metallic cable. When used inside a house and installed in a thermal installation, the ampacity of Type SE cable is found in the 60-degree column of Table 310.15b16. When preparing the cable for installation, know the correct procedure for setting up and unrolling cables from a box, roll, spool, or reel. When non-metallic sheath cable, Romex, or underground feeder cable is purchased from a local electrical supplier, is usually packaged in one of two ways. 250-foot roll, usually packaged in plastic, or on a 1,000-foot reel. When cables are in a roll, start unrolling them from the inside of the coil. If the roll was purchased in a box, a round cutout in the box is provided that indicates a starting point for unrolling the cable. If the cable is not unrolled properly, twists and kinks of the cable will develop, which could damage the cable insulation. Rolls of cable can also be unrolled easily with a device commonly called a spinner. You can see we have these in E-Lab. We do not have them in BTM. Installing the cable in the framework of a house is often referred to as pulling the cable. Route the cables through or along studs, joists, and rafters to all the receptacles, switch, or lighting outlet locations that make up a residential circuit. Always consider the following when installing a cable run. Be sure to plan the cable route ahead of time and visually line it up in your mind, just in case there's anything that comes up or you run into any problems. If holes have to be drilled in the building framing members, drill them all at the same time, making sure to maintain a minimum clearance of 1.25 inches. If you don't, remember, you need to have that steel plate that's at least 1/16 of an inch thick. When drilling holes through consecutive framing members for longer cable runs, line the holes as closely as possible to make it easier to pull cables through the holes and make the installation neat and organized. Once the cable has been pulled to all the electrical boxes on the circuit run, double check your work to make sure all locations on the circuit meet the following criteria. Make sure that you have the correct cable installed. Cable is correctly secured and supported according to the NEC. There are no twists or kinks in the cable. Cable runs have not been bent too tight. There is enough cable at each electrical box location for the required connections. When installing cables through studs and joists, there are several ways to install the cable run through the walls studs of a house. 4 methods are commonly used. The first method is to drill holes that are all a certain distance from the floor and in line, allowing for the easy pulling of the cables. So here's an example. The second method applies when there's a need to make changes in elevation along the cable run. So there's 2 ways that you can do it. So you can either do a gradual run, such as this one, where it goes up slow, or you can come up and you would make this turn here. Again, that radius has to be 2.5 times the diameter. You come up, and when it goes back in, jug handle through, and again, that one has to be 2.5 times the diameter. The third method is to drill holes close to the bottom of the studs on the outside walls. This keeps the cable run close to the bottom plate of a wall and allows for a better and easier fit for installation. So you can see this one, this bottom plate coming across, right up. The fourth but least used method involves notching the studs. So again, here's your notch. And because it's less than 1.25 inches, you need to have your protector plates here that are at least 1/16 of an inch thick. Installing cables through ceiling or floor joists is similar to installing cables through a wall. A lot of the same methods can still be used. So again, we want to make sure that this is 1.25 inches. If it's less, you need a protector plate come out, jug handle, 2.5 times the diameter, and then we're able to continue it down. You can run the cables over the joists by drilling a hole through the top plate of a wall section and running the cable above the ceiling joists. So this is in an attic. Running boards are sometimes used in a basement and are secured to the bottom of the joists in an end-to-end manner for the full length of the cable run. So the running boards are the same that you can put on a masonry wall also that we covered in the previous slide. More and more houses are being built with engineered wood. Installing wiring along or through them is very similar to installing wiring on or through traditional wood joists. Both engineered I-beams, the wood ones, come from the manufacturer with perforated knockouts, so you don't have to worry about drilling, you just got to knock them out. Other holes can be drilled in the joist, but you should always check with the manufacturer to verify that the size and location of the hole you wish to drill will not adversely affect the strength of the joist. Several of the cable installation methods previously will work with metal members, but there's a few special considerations. Much like the AC cable, where we needed the red head to go in to prevent it from getting cut along the casing, we're going to do the same thing. Once holes are punched in, the only thing we need to consider is what to cover, so that's done with grommets. So here they had grommets or bushings made of an insulating material such as rubber at each hole in the metal framing member to protect the cable sheathing from the sharp edges of the metal. Mount electrical device boxes with mounting brackets and attach to the stud with sheet metal screws or self-drilling screws. So here's an example of what this looks like on a metal stud. Plastic tie, NM cable coming down in. And remember that we need at least 6 inches sticking out. Although it's not a specific requirement, the best place to start a cable run for a branch circuit is at the service panel or sub-panel. This is considered to be the starting point of a circuit because it is the location on a circuit where electrical power is provided. It is also where the circuit overcurrent protection devices are located. The branch circuit cable run that goes from the service panel or sub-panel to the first electrical box of the circuit is called securing the cable run at device and outlet box. If you're using a single gang, non-metallic electrical device, make sure that it extends at least 1/4 inch of the cable of the sheathing into the box. So once the casing for this Romex is stripped, when at least 1/4 inch hanging in the box. Also, make sure the cable to the building framing member is no more than 8 inches from a single gang, non-metallic box with a staple or another approved method. So again, keep in mind this is a non-metallic box, and the first staple that we would need would be at 8 inches. The amount of cable that's coming out, that's going to be a minimum of 6 inches. And then again, up at the top, at least 1/4 inch of the cable sheathing into the box. For non-metallic round ceiling boxes and device boxes of 2 gang or more, or in any metal boxes, use an approved connector to secure the cable to the box. By now you should have used these in lab. These are our Romex connectors. Built-in cable clamps or a separate cable connector can be used. At least 1/4 inch of cable sheathing should be extended inside the box, and the cable should be secured with staples or another approved method within 12 inches of any of these box types. So this is the difference between the non-metallic and the metal, is that this is going to be 12 inches. The amount that comes out is still a minimum of 6, and the amount of sheathing that's left on your cable is still at 1/4 inch. When you're supporting a cable run, horizontal runs of the cable through holes in building framing members are adequately supported as long as the distance between framing members does not exceed the NEC support requirements for a particular wiring method. For example, Romex, if it's going through studs that are 16 inches on center, it's adequately supported because for Romex, you need it 4.5 feet or less. When the cable is run along the sides of a building frame member, it needs to be supported according to NEC requirements. For example, a Romex cable running along the side of a stud must be supported with staples or other approved means not more than every 4.5 feet. When installing a cable in existing walls and ceilings, it's not an easy task and will usually require 2 people to fish the cable from spot to spot. Sometimes an electrician can remove the baseboard molding around a room, notch, or drill holes in the exposed studs and run cable through. You can remove molding around doors and windows to expose a space where a cable could be run. If the service entrance panel is located in a basement, new cable runs can start at the panel and be run along the exposed basement framing members until the cable is under the wall section at which you want to install an outlet. Drill a hole from the basement up and into the cavity of the wall. Drill at the proper angle to get from the basement into the wall. Be prepared to drill through several items, including flooring, bottom wall plates, studs, joists, etc. The same drilling technique can be used when running cable from an unfinished attic space into the wall cavities of the room below. The only difference is that you will be drilling down into the wall cavities from the attic instead of drilling up from the basement. Be sure to measure accurately to avoid drilling into the wrong wall cavity or missing the wall cavity altogether and drilling out into the room, which obviously is wrong. Once the holes have been drilled for the cable, use a fish tape to determine if the wall cavity is free from obstructions. Once the electrical outlet box has been cut, install the cable through the walls or ceiling to the box location, which is usually a 2-person job. One electrician will push a fish tape through the bored holes toward the electrical box location. The other electrician will look for the fish tape at the electrical box location and will catch the end of the fish tape when it gets to the box hole. The electrician at the box hole will attach a cable to the end of the fish tape and feed it carefully through the box hole as the electrician at the other end carefully pulls the fish tape with the attached cable back to the basement or attic space. Then attach the installed cable to a junction box or to the service entrance panel. That's it, and see you next time.